Hey there, welcome to the Confident Chemistry Teacher podcast. I'm Kim, a high school chemistry teacher who's still in the classroom teaching chemistry and refining what actually works with real students. This podcast is all about practical chemistry teaching strategies, labs, and systems that make teaching feel more manageable and more confident. So let's get this reaction started. Hi everyone, today we're going to be talking about why I teach environmental chemistry as a standalone unit. In case you didn't know, April 22nd is officially Earth Day, and it's something that we recognize in all of our science classes. They'll be seeing it. Their friends might be talking about it. They might see some reels or some videos on TikTok about it. So I really like to jump on this high interest time to talk about environmental chemistry. Also, I like to teach about environmental chemistry this time of year. I know that we have testing coming up, and you might not think that you have time for anything else, but this is when students are getting a little squirrely and they're looking for why should I be learning chemistry? How does chemistry help explain what's going on in the environment, particularly with climate change? I'll also talk about the ozone layer and ocean acidification. Those are the other couple of topics that I focus on. And honestly, I think this is maybe one of those topics that I think is one of the most important that I'll teach all year. And that's because students are going to be faced with this information on the news, if not on a daily basis, at least on a weekly or monthly basis. So the first unit that I generally teach is I like to talk about the ozone layer. And there's two reasons for this. One, the ozone layer is an environmental problem that we as humans and different countries and organizations came together, and it was actually something where we believed scientists about it. We made a change, and now we are slowly reducing the hole in the ozone layer. And you can actually show your students pictures over time about how it once looked and then how it's improving now. And then we want to get into the chemistry of it. So I'm sure we all know ozone is like O3, but it's one of those really great topics that shows up in AP Chemistry, AP Bio, and AP Environmental Science. And I want the kids to know that then O3 has that double arrow, and then it's going to decompose into O2, and the O radical, that's what I like to call it. And then we talk about how it can go back and forth. It's a reversible reaction. It's also a great topic to discuss how you can have a catalyst. For example, when you talk about CFCs, that chlorine is the catalyst. It shows up at the beginning of the reaction, not in the middle of it, but then it shows up at the end. And I think that these are all great topics that are real world that your students can apply the knowledge that they've listened to. So the next thing I talk about is acid rain and ocean acidification. And this ties into things that students have already learned about, how it can affect food webs, how it can damage soil, how it can damage statues and buildings. And then I also like to show the students graphs about how the pH of the ocean has changed over time. And even though it doesn't look like it's a big change, it's depending on what you look at, between 20 and 35% of a decrease in pH over the last 30 years. And so I think it's really awesome to show the students that while the pH value itself hasn't changed, since it's a logarithmic scale, that it actually is a pretty dramatic change that's going on there. And then, depending on where it is in the year where I'm teaching this, I either use this as like an introduction to acids and bases, if I know I'm going to teach it after, or it can just be like a real life application of acids and bases. And so they can really start to see how that pH can affect real systems. Also, along with this ocean acidification idea, I do this root beer lab with dry ice, just to be clear. There's no fermentation or alcohol being made here, but the root beer lab with the dry ice is really pretty fun. It's a good review of states of matter and a good example of sublimation. I've just taught states of matter a few weeks ago. And then, of course, the kids get to drink this root beer after the fact. And we'll also do a few slight pH calculations. It doesn't show up good. You really need a digital pH meter to show the changes during the lab, but we can talk about how sodas are acidic. But if you look at the main ingredients in soda, it's actually water. So how is it that if you're adding water, you're making it more acidic? And that's, of course, because that carbon dioxide is being added, and then that's making your carbonic acid in your solution. And it does a good job of tying in ocean acidification to how sodas are acidic because you are having the addition of the carbon dioxide there. I'll also show a little video from the Alliance for Climate Education. If you just Google it or if you just look on YouTube for it, it's a really cute video, and it shows how like 1 in 7 people depend on the oceans for their food. And then there's a second video that gets more like into the chemistry of it, and it talks about how creatures that have shells need that carbonate, but the acid is reducing the amount of carbonate. It's just a really cool overall good video, and they do a better job explaining it than I'm doing right now. And then I also like to, if I have time, I have some seashells in my classroom. I'll kind of scruff them up a little bit if they're not too scruffy, and I'll have the kids drop some vinegar onto the seashells is kind of just like a quick demo about like how the acid really does impact those organisms. Another activity that I like to do is I like to talk about the greenhouse effect. And this is where we'll go ahead and we'll take some like large 1,000 milliliter beakers, we'll take some thermometers, we'll take them outside, and we'll have, each group will have 2 beakers. One beaker will just be with one thing of saran wrap on the top, and then a second beaker will have 2 or 3 layers of saran wrap on the top, and you can actually see the heat being trapped in the one with the more saran wrap in it. And so then that's a good example of like, hey, this is actually how the greenhouse effect works. This lab also does a good job of talking about like controls. Is the thermometer in the same location? Is it touching the glass? Are both beakers getting the same exposure to the sun? So I really like this one. You know, I try to save this for a nice day in April, and we'll go outside and we'll do this. We'll collect data, we'll make a graph. It has lots of good stuff in it. Another thing that's also a good tie-in is I'll talk about how coastal communities have more moderate temperatures, and about how over time we'll also sneak in a little idea about how the oceans are getting warmer, not just about how they're getting acidic. And the reason that there's only a slow change is because of the high specific heat value of water. Again, depending on where you've taught thermochemistry, thermodynamics, then you can use this as like an introduction or a review. If I have time, some videos that I'll show. I know this one is really old, you know, and depending on your political views or, you know, the values of your school system, you definitely want to watch these before you show them to your students to be aware. But some other videos I show is An Inconvenient Truth by Al Gore. I know he has a second one out there, but I just don't think that one is like as amazing as his first one. Plus, I like to bring it back, like if you've ever been to like the San Diego Zoo. I live in Vegas, and so I've taken my kids to the San Diego Zoo. By the polar bear exhibit, they have like really similar charts about how carbon dioxide levels have changed over time, and a lot of my students have been to the zoo and seen that chart, so that's a really nice connection. I will sometimes show before the flood, and there is another video by Leonardo DiCaprio that I like to show. I'm just going to say this. The girls appreciate Leonardo DiCaprio, and they're both really good videos. And then a video that I really like, but it definitely, I feel like, has a political slant to it, is The Story of Stuff. And this was crazy for me because I remember them talking in there about how companies like make things to break. We always kind of joke in my class about how their grandparents have like a broom that has to be like 50 years old. But then like in our current households, why are we having to buy a broom like every 3 or 4 years? And that's because companies are designing things to break, but still be reliable. So another reason why I really think that this unit matters is I can actually remember sitting in my high school chemistry class, yes, 100 years ago, and thinking, oh my gosh, I can actually use chemistry in like a problem that we're facing right now. So then I started to recognize, oh my gosh, this is carbon dioxide. This is what they're mentioning on the news, or they're mentioning in this documentary. Oh my gosh, this is what is happening with the ozone layer. So for me, being an MTV, if anybody even knows what that is, generation, climate change was something that we were talking about back then. And I really remember being like, dang, I maybe used another word, chemistry can actually be useful. So that's, again, maybe I have like a personal feeling of why I like to teach this unit. Now, if you're interested in doing these activities or something related to Earth Day, feel free to shoot me a message and I'll send you my lab setup that I have for it. I do want to let you know that I have a freebie on my TPT shop that is a generic environmental movie reflection sheet that they can watch. So you might want to go ahead and grab that. Like I said, it's free on my TPT shop, Kim's Chemistry Classroom. And then it also has a list of some other environmental movies that you might want to consider watching there. I also have something that I do show every time, and I show this at the beginning, actually before I jump into ozone layer, and it's called It's All About Carbon. This is a paid resource. It's only a couple of bucks on my TPT store, but it uses some NPR videos. And it really does talk about the importance of carbon and about how carbon, has 4 arms. And, in the video, it's a cartoon version of carbon, but we'll ask students, why did they draw it with 4 arms? And then it comes back, well, because it has 4 valence electrons. And then it has some other things in there, like, why does carbon have to bond with oxygen? Because oxygen is highly electronegative. But the idea is that there's 5 short episodes. Each episode is only a couple of minutes long. I'll show the video to my students. I'll have them fill out the questions while they're watching the video. We'll go over it. I'll repeat some of the corny jokes because I'm a corny joke fan that we saw in the video. If you guys watch it ooh la la, okay, you'll get it when you watch that video. So I just really like that activity. So check that out on TPT. I hope that you guys found this episode valuable. If you're looking for any of the resources that I mentioned, like the freebie or the It's All About Carbon activity on my TPT shop, check the show notes. And as always, guys, keep inspiring, keep experimenting, and keep being awesome in your classrooms. Happy teaching!